Did we do example 5? We did. All right. So kind of putting it all together, what we decided was, number 1, on a closed interval, let's summarize. What has to happen on a closed interval if the function's continuous? There has to be a max and there has to be a min, okay? And they could be absolutes.
Yeah.
Okay. If they are local or relative maxes or mins, those are going to occur at the critical numbers potentially. Critical numbers are where the derivative is equal to 0 or undefined. So that's kind of the summary. So putting it all together, if I wanted to do this, okay, in our heads, I'm going to do one that you kind of know. X squared plus 2x minus 4 is a parabola, correct? Opening up. So in our heads, we're going to know that. Let's do some algebra, and then we'll do a cubing one, okay? Putting it all together, we're going to try to first find where any local mins or maxes could be. So I'm going to take the derivative, which is what? Oh, are you looking for this?
Yeah.
2x plus 2. Okay, now what? Set it equal to 0. And this can never be undefined, correct? Okay, so we subtract 2, divide by 2, negative 1 equals x. So we call that's a critical value. A critical value does not necessarily mean that it's a max or a min. So what we're going to start dealing with this chapter is we would want to make sure that it's where the derivative changes signs, right? Remember me talking about that?
Yeah.
Because let's say, let's look at a function. Let's say there's a function, and right now that function has a positive slope, and then it has a 0 slope, and then it has a positive slope again. Has an extrema occurred?
No.
No, because the derivative did not switch signs, the slope. However, if it had a positive slope 0 and a negative slope, that becomes a local max. And all right, so this is pretty easy to check. Let's put negative 1 on here. Let's pick something to the left of negative 1. Remember, this is on the closed interval, negative 2. So I can check negative 2 if I want, or negative 1.5. If I put in a value like that, would this be positive or negative? Plug in something. Yeah, 2 times negative 1.5 is negative 3. Negative 3 plus 2 is negative. Okay. The slope is negative over here. Over here, let's pick, I don't know, 0. What's 2 times 0 plus 2? Okay. So this is going to be a, let's see, negative to positive. This is going to be a local min. At x equals negative 1. Okay. So I've now identified the relative one. And when I'm checking for absolute, I want to check the relative and the endpoints. And so when I say check, this is on the original function, we're going to plug this critical value and the endpoints, which were, what was the interval? Negative 2, 1, and we're going to evaluate them and figure out which one gives us the highest and the lowest of the function. So first, let's start with the negative 2. Remember, we're going to the original. So we have negative 2 squared plus 2 times negative 2 minus 4. So we have 4 minus 4 minus 4. 4 minus 4 is 0. 0 minus 4 is a negative 4. All right, let's plug in my next value, which is my negative 1. That's where the local, we know there's a local min there, okay? When I plug negative 1 squared in, Negative 1 squared is 1. 1 minus 2 minus 4 is negative 5. Ooh. So far, that's lower than negative 2. And then let's check in with our positive one. I'm picking positive one because it's the right end point. Okay, so for extrema, you have to check locals and the endpoints. So we have 1 squared plus 2 times 1 minus 4. That's 1 plus 2 is 3. 3 minus 4 is negative 1. Okay, let's summarize. So, absolute, or sorry, let's start with local. Oh, it just says the absolute. Okay, well then we'll just do the absolute. All right, so we're going to say absolute max. What is it? Yep, it occurs at 1 and the value is negative 1. So if I asked where it occurred, it would be at x equals 1. If I asked what the max was, you would tell me negative 1. Okay? And what's the absolute min? It occurs at negative 1 and the absolute min is negative 5. And I did all of that with not one time looking at the graph, only using calculus. Let's see how we did. Okay, so if I was tracing and I was starting at negative 2, this function starts down here. Do you see then that's why the absolute minimum is down here, because it starts here and then it goes down and then it goes up. So if I was just doing that little snippet of the graph on that closed interval. Does that make sense to you? That process? Okay. Let